Hi friends, in this problem we are given this upper triangular matrix. This part all of them are zeros and this upper triangle all of them are ones. So ideally matrix multiplication should become easy. Now we are given this matrix which is actually sum of a, then a square, a cube up to a power 20. Right. Obviously there must be some pattern in a square, a cube and so on. We have to identify that pattern and find out what exactly is this M. Right. Clearly, this is upper triangular matrix. Let us try to find how this is coming out. How is it? How is a square coming out? How is a cube coming out? Basic matrix multiplication. If you do, then a square it becomes 1, 2, 3, 0, 1, 2, 0, 0, 1. If you do the plain multiplication. Right. So here, obviously, upper triangle matrix, we got another upper triangle matrix. The diagonals are ones and a square. There seems to be 2 and 2 here, and there seems to be 3 here. Right. Similarly, a cube, that is this a square into a once. Right. That is becoming again diagonal matrix is 1, 1, 1. This 3 is becoming 3 here, and this a cube has become the first row and the third column. This element has become 6. Right. So this 6 when it is 3 and it is 3 when it is 2. It is looking like this 3 is nothing but 1 plus 2 and this 6 is nothing but 1 plus 2 plus 3. Right. So, and it is looking like this a power n. If you do this, then this diagonal matrix will remain as ones and these two elements will remain as n's because it is n and this first row and third column. This is looking like sigma n, right? So, but we can feel it intuitively that this is sigma n. But still, if you want to prove it, then how do you prove it? We use mathematical induction. For example, we take this a power n and multiply this with this, let's say a, right? Then what will happen to a power n plus 1? A power n plus 1, let's say if you want to calculate this first row and third column, that means multiplication of this and this one. First row, this is first row and third column, that is 1 into 1 plus n into 1 plus sigma n, that is 1 plus n plus sigma n, which is nothing but this is sum of first n natural numbers plus n plus 1. This is nothing but sigma n plus 1. So now we are sure that a n plus 1, this element is becoming sigma n plus 1. Similarly, we can show that these elements are also n plus 1 and n plus 1. Right. We can do this entire multiplication, that a power n into a. If we do this entire multiplication, we will get this matrix. 1, n plus 1, n plus 1, 1, 1, remaining zeros. And this one is becoming sigma n plus 1. Right. So now with this we can actually prove that this is actually this is a general form of this a power n. Right. Now, what we want, we know what is a power n. We want a plus a square plus a cube plus up to a power 20. That means there are 20 such matrices. First matrix is all ones. Second matrix, then 2, 2, and 3 here. Third matrix will be 3, 3 in this part 3, this part 3. And this one will be 1 plus 2 plus 3. That is 6. Similarly, the final matrix or the nth matrix will be diagonal ones, then n and sigma n. Now if you want to add all of this, then this, because these are 20 matrices, right? Then all 20 matrices, these diagonals will be 1 plus 1, 1 plus 1 up to 20. One here, one here, one here, one here, whatever, likewise 20 ones. So this diagonal will default be 20, right? Diagonal is anyway 20. Now, what about these two elements? This element and this element. If you are looking at A12, right, of this matrix M, that is sum of this 1 plus 2 plus 3 plus 4 up to n. That is 1 plus 2 plus 3 up to n, which is nothing but n into n plus 1 by 2. And how many are there? N is 20 here. 1 plus 2 up to 20. So 20 into 21 by 2. That is 210. 20 into 21 by 2, 210. Those are these two elements. So fantastic. We are able to figure out these two elements of our final matrix and these three elements of our final matrix. These are anyway zeros, right? Because all the 20 matrix These three elements are anyway zeros. So this is anyway zeros. These three elements are anyway zeros. Now we are left with the final one. What is the final one? That is first row and third column. That is 1 plus 3 plus 6 plus whatever, which is nothing but 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus 1 plus 2 plus 3 plus 4 plus up to 1 plus 2 plus up to 20. This is the sum that we have to do, which is nothing but first element is 1, second element is 1 plus 2, this is 1 plus 2 plus 3, this is nothing but sigma n. Right. So first, this entire summation is nothing but sigma of sigma n. So what is sigma n? That means the nth element or the rth element, let's say r plus rth element of this entire sum. That is, if let's say if r is 3, the third element is actually the sum of first three natural numbers. The fourth element is nothing but sum of first four natural numbers. The tenth element is nothing but sum of first 10 natural numbers. Basically, this is sum of first 10 natural numbers. That is this summation, right? Sigma of sigma r, and r is going from 1 to 20. Sigma of sigma r. That means that. Now, what is sigma r? Sigma r, that we know. So sigma n is n into n plus 1 by 2. Right. So the nth element of this summation of sum of series is r into r plus 1 by 2, the rth element. Right. So now what is our total sum? Total sum is, if we do this, this becomes r into r square plus r by 2. This 1 by 2 we can bring it outside, and we know sigma of r square. Sigma r square, sum of squares of first 10 natural numbers is n into n plus 1 into 2n plus 1 by 6, or r into r plus 1 into 2r plus 1 by 6. This is sum of first squares of first n natural numbers. Here we have 20. So 20 into 21 into 2 times 20 plus 1. That is 41 by 6 plus sigma r, which is nothing but 20 into 21 by 2. And this half is anyway outside. If we simplify this, this becomes 1540. That is our number. Right. So this this number is actually summation of summation of first n natural numbers, which is nothing but this simplifies to sigma of n into n plus 1 by 2, which is nothing but sigma of n square by 2 plus sigma of n by 2. That is what we have done. Right, guys?